Alright, so this will be a video on set differences and power sets, which is yet another operation you can do on sets, and we'll just kind of get right into it. But basically, our classic set A, this time I have elements 1, 2, and 3, and set B, 3, 4, and 5. And you can denote the power set of A in a couple different ways, but I'll just use the ones that are pretty common, I think. You can write, P of A, that just means power set of A. Or you can also write 2 raised to the A power, and that kind of comes from computer science. You can kind of think of like binary. Well, not quite that way. But basically, you can kind of think of it in terms of like the amount of possible combinations you have of something. And basically, it's not that important where it comes from, but that's just kind of a little aside. So basically, what a power set is, it's the collection of all possible subsets of your set. And so basically here I have this outermost curly brace. And so remember, the null set is a subset of every set. So actually I didn't cover that specifically before, but for now we're just going to say it's a subset of every set. We're going to revisit that concept later. But basically the null set's a subset of this set. You have 1, because you can take 1 out of this and leave these 2 alone. That's a subset. 2 is a subset, 3 is a subset, and you can also have 1 and 2, that's a subset. And basically you can kind of see where this is going. Every possible combination of subsets is included in the power set of A. And basically you have 1, 3, 2, 3, and you have 1, 2, and 3. Because remember, if you have if the set's identical, it's also both a subset and a superset of itself. And basically for B, now I'm going to talk about the set difference, and that's the set difference is kind of defined in this way. You have X is a member of B and X is not a member of A. This is logical conjunction. If you're not familiar with this notation, it really just means both this condition and this condition has to be true for this whole expression to be true. That's what this little fancy caret means. And so basically, you have all the members of the B slash backslash A. That means set difference, and that like I said, all elements of B that are not in A. So basically, you kind of think of it as yes, a member of that one, not a member of that one. That's kind of how I look at it. And so let's see, 4 and 5 are a member of B. 3 is a member of both A and B. So that's not included in the set difference. And so basically, you can just say 4 and 5 is a set difference of A and B. And there really isn't too much more to the concept than that. And I promise we're going to be doing stuff a little bit more exciting than just looking at set operations in this playlist. If you guys already have some background in set theory, you'd probably be better off fast forwarding. Well, not yet, but eventually when I get to the series, when I get to the videos where I talk about the continuum hypothesis, you probably want to fast forward to that. I'm just not really doing anything too fancy right now. They're just basic set operations. You can kind of make up your own examples and practice them, and I guarantee you after about like 4 or 5, you'll just completely understand exactly what's going on. They're not too complicated at all. So that's pretty much it's a good stopping point for this video, and I'll see you guys in the next one.